Hello, algebra students. Welcome back. In this video, I'm going to talk to you about absolute value and absolute value inequalities. My goal is to define for you what an absolute value is, define absolute value inequalities, and in that definition, try to kind of explain what they mean and how we can use them. And then I want to do an example where I can show you how to solve an absolute value inequality. So, just to start us off with a simple definition, the absolute value of a number is its distance from 0 on a number line. So let me give you an example. The absolute distance, the absolute value of the number 3 on a number line. So here's our number 3, and that is 1, 2, 3 units from 0. So that would be 3. The other number that has an absolute value of 3 is actually -3. So here is -3, and its distance from 0 is also 1, 2, 3. So that would also be 3. So the absolute value of 3 is the same as the absolute value of -3 is the same as 3. So we can use this to solve some simple kind of equations. Let me give you an absolute value equation here. Example. If I told you that the absolute value of a number x is equal to 5, you would look at your number line, or maybe imagine it, and you would say that there are actually 2 answers to this equation. So from 0, if I go 5 units in the positive direction, 1, 2, 3, 4, 5, the absolute value of x would be 5. But I could also go 5 units in the negative direction, 1, 2, 3, 4, 5, and that number would also have an absolute value of 5. So the solution to this is x could be -5 or 5. Both of those numbers have an absolute value of 5. But of course, our equations are usually going to be a bit more complicated than this. So let's kick it up a notch. Let's say I had an equation that looks like this. All right, so the absolute value of a number -2 is equal to 1. We can kind of reason this out using the same number line logic that we had before. So let's say I have -3, -2, -1, 0, 1, 2, 3, and 4 on a number line. And what I'm seeing from this equation is that when I look at whatever this number is in the absolute value, x minus 2, the distance from 0 is 1. So that could be 1 in the positive direction here, or it could be 1 in the negative direction here. So those are 2 possibilities for what my number x minus 2 could be. X minus 2 could be -1, or it could be +1. So I can look at it like this. X minus 2 could be -1, or x minus 2 could be +1. Those are my 2 possibilities there. And then I can solve each of these little equations. And luckily, they're really similar to solve here. I'm going to do it in yellow. If I add 2 to each side here, I get x is equal to 1. If I add 2 to each side here, I get x is equal to 3. And these would be my two solutions. X could be equal to 1 or 3. And if you check those by plugging them into our original equation, x minus 1, absolute value, or I'm sorry, our original equation, which was the absolute value of x minus 2 is equal to 1. So if I plug in 1 into that equation for x, I get 1 minus 2, absolute value is equal to 1, and then I get the absolute value of negative 1 is equal to 1, and that's true. Negative 1 is 1 unit away from 0, so that checks out. And if I plug in my other answer, x is equal to 3, if I plug that in for x here, I get 3 minus 2, absolute value is equal to 1. And that tells me the absolute value of 1 is equal to 1. And that's true too. So that's how we can work a little bit with absolute value in terms of equations. Well, let's talk about what happens if we are doing an inequality. And we'll use kind of that same logic to figure out what's going on here. Let's say I tell you that the absolute value of x is less than 3. Taking a look at our number line, what this is telling me is that our distance from 0 is smaller than 3. So what I'm going to do is I'm going to look at the points that I have a distance from 0 of 3. So here, my distance from 0 is 3. And here, my distance from 0 is 3 in the negative direction. But I'm looking for things that have a shorter distance. So I'm actually looking at all these numbers in between -3 and 3. Each one of these numbers is closer to 0 than 3 units. And you could, of course, write this in interval notation. Say the answer to this is all the numbers between -3 and 3 are closer than 3 units to 0. Let's do an example of something where we're looking at the distance farther away. Let's say the absolute value of x is greater than or equal to, let's say, 4. So looking at our number line, we have 0, 1, 2, 3, 4, 5, and so off towards infinity. -1, -2, -3, -4, and -5, and so off towards infinity. And I know that I'm looking for things that are farther away from 0 than 4. So I take a look on the positive side and I say, well, here's 4. That's exactly 4 units away. And remember, I have that equal sign. So I'm looking for 4, but also anything larger than 4. Anything farther away than that. And I know that -4, look at that, that's 1, 2, 3, 4 units away. But I also want to include anything farther away, down towards this direction. So this is kind of interesting. Instead of the numbers in the middle, instead of all of these numbers in the middle, we have numbers on either side. That makes our interval notation really interesting. I'll show you what that looks like. So these numbers are too close to 0. We don't want to include those numbers. We don't want to include anything between -4 and 4. These are all too close. Too close. But we do want to describe all the numbers highlighted in red and all the numbers highlighted in green. So here's what we do. Just talk about what we see in the red in integral notation. Only worry about that. That's all the numbers between negative infinity and -4. Bracket. I'm including -4 because we also want numbers that are exactly 4 units away from 0. And now just describe what we have in green. All the numbers between +4 and infinity. So now we've described each piece of the number line, and we use this special symbol here. I'm going to write it in white, this U, to glue them together. This U symbol is called the union, and it means that we want to include both of these in our answer. So if you're reading this out loud, you would say all the numbers between negative infinity and -4, including -4, along with all the numbers between +4 and infinity, including +4. And that's how you would write your answer here in integral notation. But of course, we're going to deal with a little bit more complicated equations. So let's kick it up another notch. And remember, you can always rewind these videos if you're like, no, Sarah, don't kick it up another notch. You can watch it again, or you can read through the textbook on Lumen and see if you like their explanation better. Also, there's a lot of great math resources on YouTube. I will not be offended if you look for other information that's out there. So now let's try this. X minus 7 is greater than or equal to 2. So we have a pretty good idea, based on our other examples, of what to do. We can start off with our number line. And this symbol is telling me I'm looking for things that are farther away from 0 than 2 units, or are exactly 2 units away from 0. So I'm going to look at the positive direction. I'm going to say, well, 2 is 2 units away from 0. And all those numbers to the right of 2 are farther away from 0. And -2 is exactly 2 units away from 0. And all those numbers to the left would also be farther than 2. They would also be farther than 2 units away. So we can have this situation. We could have x minus 7 could actually be smaller than or equal to -2. We could have x minus 7 be greater than or equal to +2. And that's going to mean that we get the right answer here. And then we'll solve this little equation. Add 7 to each side. And why not? Let's do it here too. And then we get x could be less than or equal to 5. And x could be greater than or equal to 9. I'm going to graph that on a number line just because I want you to see something kind of interesting here. I want you to see something a little bit interesting. So let's go ahead and start at -2, -1, 0, 1, 2, 3. My handwriting's bothering me here. 3, 4, 5, 6, 7, 8, and 9. So we could have numbers greater than or equal to 9. And we could have numbers less than or equal to 5. All of this. So here's what I think is kind of interesting. Let's look at the middle of our graph here. 1, 2, 3, 4. We have a space of 4 there. 1, 2, 3, 4. We have a space of 4 there. Oh, interesting. Same gap. So we just moved our original solution to the right by some amount. So how much did we move that? We translated it, we transformed it, for those of you who remember. So what's the distance between -2, this left end point, and 5, this end point, if we look at that? 1, 2, 3, 4, 5, 6, 7. Take a look at that 7. Those are some interesting connections. We'll talk about that more in class. I just wanted to show you a little bit. So this is just to get you excited. We'll talk about this more. I do want to show you one example, step by step, of how we solve an absolute value inequality. So let's say we have a more complicated situation. Now we've got multiplication involved. We have 3x plus 7 is greater than 4. We can break this into two linear inequalities, the positive and the negative version. So we could have 3x plus 7 is greater than 4, or we could have 3x plus 7 is smaller than negative 4. And then we solve each one of these little inequalities, subtract 7 from each side, and then we get 3x is greater than negative 3. Divide each side by 3. You get x is greater than negative 1. And we can solve this other little equation over here. Oh, I said equation. That's not true. It's not an equation. It's an inequality. I could subtract 7 from each side, and I get 3x is less than negative 11. And then I could divide each side by 3. I would get x is less than negative 11 over 3. It might help you to sort of mentally estimate this fraction, kind of where that is. Think of it as a mixed number so that when you're looking at the graph or you're thinking about your interval notation, you have an idea. I sort of mentally translate this, and I realize that this is about negative 3 1/3. So that helps me for this next part. I'm thinking about interval notation. If you're still working on interval notation, I think graphing the number line really helps, and I would recommend that you do that. So here's my number line, and I know that I'm looking for numbers that are larger than negative 1 and smaller than negative 11 over 3. So, okay, here are numbers larger. Let's do it in yellow over here. Larger than negative 1. And we'll do in red over here. Smaller than negative 3 1/3. We'll say negative 3 1/3. It's right about here. And we're also looking for numbers smaller than that. This is why I recommend graphing it, so that you can see. I'm actually trying to talk about this piece of the number line and this piece of the number line. So in the red first, we would talk about this as negative infinity all the way to negative 3 1/3 or negative 11 over 3. And in the yellow, we would talk about that as negative 1 all the way to positive infinity. And then we use that union symbol to glue them together. That would be our final answer there in interval notation. I hope that's helpful to you. And there's going to be lots more practice on this on your homework. So if you need, take a look there. I hope that this has been helpful to you. The next section is about graphs and points in the plane. So it's basically about graphing and plotting points.